So, good evening. Today I am going to discuss bivariate data. Okay. So, have you any problem? Please write in the comment section. I immediately respond. Okay. So, can you tell me? Are you hearing me? Are you hearing me? Please write in the comment section. Yes and no. Okay. Ashwato. Good evening. So, if you have any problem, please write in the comment section. I will immediately reply you. Okay. So, no problem. Okay. Yes. Thank you, Sashoto. So, today I'm going to discuss bivariate data. What is bivariate data? So, bivariate data, this is a paired data. The definition of bivariate data is home of a good evening. Data on please tell me, can you read my handwriting? Shashwat Shambhu, please tell me, can you read my handwriting? Yes. Then write yes, otherwise I need to change. Okay. Can you see my, can you read my handwriting? Okay, thank you, Shashwat. So data on two variables recorded simultaneously for a group of individuals are called bivariate. Yes, Dr. Prabhu, thank you. So please communicate with me via comment box. Please write your comment and I will reply immediately. Are called bivariate data. For example, heights and weights of the students in a class. Yes, Nilmallo, good evening. So note that suppose you have a 10 student, okay? So student 1, I denote this by serial number 1, student 1, student 2, up to student 3. So you take height of student 1 and weight of a student 1, then this is a bivariate data. But if you consider height of student 1 and weight of student 2, then this is not a bivariate data. Bivariate data means you take simultaneous observation from same individual. Okay, if that individuals are different, if you take a height of student 1 and height of student 2, height of student 1 and height weight of student 2, this is not a bivariate data. Yes, it is a paired data, but it's not a bivariate data. For bivariate data, you should take two observations from same individual. Okay, clear? Have you any question? So, second example, the rainfall and yield of paddy in a state for several consecutive years. Another example, the marks obtained by a group of students in the test and the final exam. See, rainfall and yield, you take a simultaneous two observation from each year. So this is a bivariate data. Marks in test marks, the test marks in the test examination and final examination for a particular student. So this is a bivariate data. Similarly, another example, the income and expenditure of a number of families. So you take the same income and expenditure from same family. So that's why this is the bivariate data. So these are the example of bivariate data. So do you understand what is bivariate data? If you have a still problem, please tell me. So G host, good evening. Please tell me, have you any problem regarding the definition of bivariate data? Bivariate data means you take a simultaneous two observations from time, you take a two observations simultaneously from the same subject, same group. This is called bivariate data. Okay, please respond. Please tell me, have you, if you need more explanation, please tell me. Karshoto, okay. So when we have bivariate data, we can no doubt consider the values of each variable separately to know the different measures. Okay, Shashwat, sir, the values of the two variables must correspond to the same individual. Yes, Shashwat, same. That's why this is called bivariate data. You take a simultaneous observation from same individual. Okay, so for consider the example one, I take the height of Shashwat and weight. Okay, then suppose you have 11 students. I observe there are 11 students watching this video, and I take from each student height. I take height and weight from each student. So that's why this is a bivariate data. If I take uh, five weights from five different students and six height of another uh, six different students, this is not a bivariate data. Bivariate data means it takes simultaneous observation from same individual. I take If I take height and weight from Shashwat, then this is the bivariate data. If I take a height from Shashwat and weight from Sharnavo, this is not a clear observation. This is not a bivariate data. Clear, Shashwat? So please tell me, clear? Okay. So when we have bivariate data, we can no doubt consider the values of each variable separately to know the different measures like the mean and standard deviation of the variable. I think you know the mean. This is the measure of central tendency, and standard deviation. This is the measure of dispersion. Okay, but here we are mainly concerned with two other problems. One, firstly, we want to study the nature and extent of association if in between the variable. Secondly, if the variable if the variables are found to be associated, we express one of them regarded as the dependent variable. Sometimes it's called response variable as a mathematical function of the other. This is called independent variable, or sometimes it's called regressor or explanatory variable. Independent variable or regressor or explanatory variable. So that we can predict the value of the dependent variable when the value of the independent variable is known. The first problem, the problem 1, this is called correlation analysis. And the problem second problem is called regression analysis. When there are data for a considerably large number of individuals, they are summarized in a two-way frequency table. A suitable number of classes are taken for each variable keeping in mind the same course considerations as in the univariate case. So I think you know the how to construct frequency table in univariate data. So we apply same procedure here also. Suppose we are given in n pairs of values of variables x and y. There are two variables. I denote these by x and y. If there be k classes for x variable and L classes for y, the frequency table will be table will have k cross L cells with the help of tally marks, we can find the frequencies of different cells. The whole sets of class frequency plus frequencies of this define the bivariate frequency distribution of variables x and y. So suppose I consider three classes of x variable, and we know these classes are first class x0 to x1. X0 is the lower boundary and x1 is the upper boundary of this class. Similarly, for the second class, x1, x2, and the I plus is xi minus 1 to xi, and kth class is xk minus 1 to xk. Okay. This is total. This is the marginal total, and for variable y, consider L classes, and the first class is y0 minus y1, second class is y1, y2, jth class is yj minus 1, yj. This is the lower limit, yj minus 1, and upper limit is yj. And lastly, this is the L class. YL minus 1 is the lower class limit, and YL is the upper class. And this is the marginal total corresponding X. So, for the first cell, suppose the number of cases occurs in the corresponding x0 to x1 and y0 to y1, that is denoted by f11. This is the frequency of first cell. Similarly, f12, this is the frequency of second cell. This is the frequency of 1jth cell, and this is the frequency of 1lth cell. Similarly, f21, this is the frequency of 21th cell, 22th cell, 2jth cell, 2lth cell, fi1, fi2, fij, fil, and lastly fk1, fk2, fkj, fkl. And the sum of this frequency, that is f11 plus f21 plus fi1 plus fk1 is denoted by f01. Similarly, the sum of this frequency is denoted by f02. So, sum of this frequency is denoted by f01. Sum of this frequency is denoted by f02. Sum of this frequency is denoted by f0j, and lastly, sum of the last column is f0l. Similarly, sum of this frequency corresponding to first row is denoted by f10. Similarly, for second row, the total frequency is f02. ith row is fi naught, and the last row is a naught. Okay, Shayok, this is quite familiar, like Punnett square of biology. Maybe, Shayok, I have no idea. Thank you. So here fi naught is sum over I fij, and f naught j sum over j fij. In the above table, the row totals of frequencies give the number of individuals belonging to different X classes irrespective of their Y values. So the first and the last column together present the Shashwat, sir, are the suffixes of the frequency made according to the matrix row and column marking? Yes, Shashwat. Yes, yes. Fij is the frequency of ij cell. Yes, absolutely right. So the first and last columns together presents the frequency what is the meaning of zero in total. Zero in total means zero. Okay, so this is a notation. Notation, fi naught means here you take a sum over uh, fi naught, you take a sum over j. Okay, so that's why I denote this symbol zero. Zero means uh, because you take a sum of all the if sum over j. That's why this is fi naught, and I denote this fi naught. And similarly, this is, sorry, you were right. So it should be sum over I. This is a notation. Okay, Shashwat. So I want to say fi naught, like if f1 naught means f11 plus F12 plus F1J plus F1L. You take the sum over J. I did so that's why this total marginal total. This is called marginal total. It is a frequency corresponding the class x0 minus x0 to x1. Okay. Similarly, F2 is F21, F22, F2J plus F2L. For ith class of X, the frequency is Fi0. It's a marginal frequency. Fi1, Fi2, Fij, Fil. This is denoted as sum over J running from 1 to L, Fij. I denote this sum by Fi0. Okay. Similarly, F1 means F11 plus F21 plus Fi1 dot plus Fk1. And similarly, F02 is a sum of the frequency F12, F22, Fi2, Fk2. That is the frequency corresponding to the class Y1 to Y1 to Y2 of Y variable. So this is the total marginal frequency, marginal total. Okay. Similarly, F0J, this is nothing but a F1J plus F2J, Fij plus Fkj, which is written as a sum of I from 1 to k, I running from 1 to k, Fij, which is denoted by F0J. This is the frequency corresponding to the class Fj1 minus Fj, that is jth class of variable y. Okay, and so on. Thank you. So the last column together presents the frequency distribution of the variable called the marginal distribution of x in connection with the bivariate distribution. That is, I mean to say, this F01, sorry, that is F1 naught, F2 naught, Fi naught. These are the, this gives the marginal distributions of x. Okay. Similarly, so please wait. There is a problem. Okay. So similarly, the first and the last row which shows which shows which shows the different y classes and the corresponding frequencies give the frequency distribution of the variable y called the marginal distribution of y. Again, any particular column of frequencies shows the number of individuals belonging to different x classes for the given values of y. This is called the conditional distribution or array distribution of x for given y. Similarly, any particular row of frequencies gives a conditional distribution or array distribution of y for given x. Okay. So please tell me, have you any problem? So please tell me, no problem. If you have a problem, please tell me, no problem. You do not hesitate, okay? Please tell me. শাশ্বত, জিৎ, সায়ক, নির্মাল্য, অর্ক প্রভু, please tell me, have you any problem? Any difficulties? Please tell me. Okay. Marginal distribution means actually marginal distributions means these are the bivariate. If you understand the bivariate, but marginal is eliminating the effect of, if you interested in marginal distribution of x, then you need to eliminate the effect of y. So that's why if you add all the frequencies, let's see. Okay, please wait. Okay. Okay, fine. So see, if you look at this f1 naught, here if you add all the frequency f11, f plus f12, f1j plus f1l, that means you eliminate the effect of y. Okay, so this gives the marginal frequency corresponding to the class x0 to x1, first class of x0 to x1. Okay, Nirmallo, Jit, understand? Again, see that in x, because you marginal distribution means you eliminate the effect of one variable. So if you interested in marginal distribution of x, then you need to eliminate the effect of y. How to eliminate this? Just add up the all frequencies on a first row. This gives the marginal frequency corresponding to the class x0 to x1. This means this eliminate the effect of all the classes of y. Similarly, for second class of x, you need to add all these frequencies, frequency of the first, second row. That means you eliminate the effect of y. So this gives the marginal frequency corresponding to the class x1 to x2 and so on. Clear it? Similarly, you do same thing for marginal frequency distribution corresponding to variable y. So in that situation, you need to eliminate the effect of x. And how to eliminate this? Just add up all the frequency for a particular class of y corresponding all the classes of x. That means if you, for f01, you see that I add all this frequency corresponding to the all classes of x for a given y0 to y1. This gives the frequency of class y0 to y1. Similarly, this gives the frequency of y1 to marginal frequency of y1 to y2 plus the sum of the actually this is called the column sum. So column sums gives the marginal frequency corresponding to the variable y, and row sum gives the marginal frequency corresponding to x. Clear, Jit? Okay, thank you. Thank you, Jit. So next thing is, this is the diagrammatic presentation of bivariate data. This is called scatter diagram. A scatter diagram is a diagrammatic representation of bivariate data. Suppose we are given 10 pairs of values of variables x and y. Shayo, sir, please explain conditional distribution again. Shayo, I will discuss later, okay? First finish this scatter diagram, then I will answer your query, okay? Please wait. So, okay. So Shayo asks me, sir, please explain conditional distributions again. Conditional distribution, I define conditional distribution as for given y, is, listen carefully, any particular column of frequencies shows the number of individuals belonging to different x classes for given values of y. Okay, so if you consider any class, that is the first, suppose I interested in the first, if you look at the first column, okay, if you look at the first column, then you see that F11, F21, Fi1, Fk1, these are, okay, these are the conditional distributions or array distribution of x for a given y0 to y1 for this particular class. Okay, for particular class y0 to y1, if you look at the definition, then any particular column of a frequencies, you take the first column, the number of individuals belonging to different x classes for given values of y. So this for given values of y, for a particular values of y, suppose if we consider the any value lies between y0 to y1, okay, so then the corresponding different frequency of this class, this gives the conditional distribution or array distribution of x given y. That means I want to say f11, f21, fi1, fk1. These are the collectively, these are the conditional distributions of x for given y values, for given y, the y which y lies between y0 to y1. Clear, Shayo? Please tell me. Please tell me. Please see the definition. If you look at the any particular column or any particular row, if you are interested in the conditional distribution of x given y, then you look at the any particular column, and if you are interested in a if you are interested in the conditional distribution of y given x, then you look at any particular row. Then this particular row or this particular columns gives the condition. If you consider particular rows, then these rows, the frequencies of these rows gives the sorry, the rows gives the solve. What is the difference between conditional and marginal? Marginal is different thing, child. Marginal is eliminating the effect of y. Look at this. Suppose if you interested the marginal of x variable, then the frequency of I think if I take first class, it is better to take first class. Okay, first class of x, that is x naught to x1. So the marginal frequency of x naught to x1 is nothing but a f11, f12, f1l. This is a marginal frequency of the class x naught to x1. Why? Because here I am eliminating the effects of y by adding all the frequency. Okay, but the conditional frequency or conditional, if you look at the conditional distributions for different, I think I did a mistake. According to my notation, it should be sorry. It should be f11 plus f21 plus fk1. So this gives the marginal frequency corresponding class x of x1. But if you interest the conditional frequency, the conditional frequency, all are the conditional frequency. f11 is a conditional frequency of the class x naught to x1 for given y naught to y1. f21 is a conditional frequency of x naught to x1 given y naught to y1, and so on. These are the conditional frequency, and x naught to x1 is a and f11 plus f21. If you add all this frequency, see, listen carefully. f11 is a conditional frequency of the class x naught to x1 given y naught to y1. f21 is a conditional frequency. I think it is better to write generally. That will be that help you much. Okay, so I consider the frequency corresponding yj minus 1 to yj, that is jth class of y. That is, I denote this by f1j, f2j, fkj. Okay, sir. So this is a conditional frequency corresponding x0 to x1 this class for given yj minus 1 to yj. Similarly, f2j is a conditional frequency corresponding x0 x1 for given yj minus for given yj minus 1 to yj, and this is the conditional frequency corresponding xk minus 1 to xk for given yj minus 1 to yj. Okay, these are the conditional frequencies, and if you add all this frequency, this gives marginal frequency corresponding class yj minus 1 to yj for y variable. So if you add all this, this eliminates the effect of x, this eliminates the effects of x. Okay, so this gives the marginal frequency corresponding to class yj minus 1 yj for y variable, and each component, these are the conditional frequency corresponding the different class of x for given yj minus yj. Okay, Shayo, clear? Please tell me. I'm waiting. No problem. If you have still any problem, please tell me. Shayo, can I explain more? You need more explanation? Each component, these are the conditional frequencies corresponding x0 x1 x1 x2 xk minus xk for given yj minus 1 yj minus 1 yj respectively, and sum of this conditional frequency gives the marginal frequency corresponding yj minus 1 yj minus 1 to yj for given y variable. Right? Okay, thank you. Clear? Please tell me. Are you satisfied? Yes, and no problem. If you have a problem, please tell me. This is the time. If you have a question, please ask me. I'm enjoying. Chayo, Chayo, clear? Okay. Thank you. Thank you. So, suppose we are given n pairs of values of variables x and y, taking two mutually perpendicular straight lines as axis of reference for x and y, each pair of given values can be plotted as a point in the graph paper the figure obtained when all the in pairs of values have been plotted is called a scatter diagram, or sometimes it's called dot diagram. Okay, so this is the x-axis, this is y-axis, and we plot the pair observation, and it looks like this is called scatter diagram. From scatter diagram, one can know the nature and the intensity of association if any between the variables under study. If we observe that as x increases, y also increases, then this is called, then in that case x and y are positively correlated. Similarly, as x increases, y decreases, then this means x and y are negatively correlated. And the diagram look like? This means it suggests there is a nonlinear relationship between the data. And if as x increases, y fixed, or y increases x fixed, that means it's look like, then this is called zero correlation. That is, x and y are uncorrelated. Moreover, we can also tell the strength of correlation using scatter diagram. For example, suppose this means x and y are positively correlated. Again, this is also means x and y are positively correlated. But the strength of correlation, strength of association is much more stronger in this case. See, I denote this by case 1, case 2. So strength of association between x and y is much more stronger in case 2 than case 1. Because in case 2, we see that it is very much close to all the point, very much close to the straight line, whereas in case 1, the points are not so close as case 2. So that is why we can say the strength of correlation, even both are positively correlated, but strength of correlation or association between x and y in case 2 is more stronger than strength of correlation between x and y in case 1. Similarly, for negative correlation, we can get same conclusion. So this means this is the negative correlations. As x increases, y decreases. Both cases are the example of a negative correlation, but here we say that case 4 is more stronger than case 3. Okay. So from scatter diagram, we not only say the association, direction of the association between linear association between x and y, we also say the strength of the association between x and y. Okay. Now we consider how to measure the association between two variables. Okay. Can I rub this portion? Please tell me. So one point I should mention, that is the drawback of this scatter diagram is, or limitation of this scatter diagram, you note this thing. it is not a suitable method when number of individuals is very large. So we need a measure. How to measure this association? I'm going to discuss this. This is called correlation. Okay. A correlation, by correlation we mean the association or interdependence between two variables. If two variables be so related that a chance if the two variables so related that a change in the magnitude of one of them is accompanied by a change in the magnitude of other, they are said to be correlated. Correlation may be linear or non-linear. Here we shall restrict our discussion to the situation where the correlation is linear. Now, if one variable is found to increase on the average as the other increases, the variables are said to be positively correlated. Again, if one variable decreases on the average as the other increases, they are said to be negatively correlated. The third situation may arise where as one variable increases, the other remains constant. On average, in this case, this is the case of zero correlation, and the variables are said to be uncorrelated. So these are the scatter diagram. Now look at this diagram. If you shift the scale and origin, actually if you shift the origin to from 0 to x mean x bar y bar, then you see that this is first quadrant. If we divide all four quadrant as first, second, this is third, and this is fourth. Okay, So if you did, you look, you see that for positive correlation after shifting origin to 002 from 002 x bar y bar, means of x and means of y, then you see that for positive correlation maximum points falls on first and third coordinate. Okay. Similarly, if you look at the second graph and if you shift its origin from 002, its mean x bar and y bar, then we see that maximum data fall on second and fourth coordinate. Okay, clear? Please listen carefully. Again, I repeat. If you look at, so I denote this new axis by x dash, that is x minus x bar, and this is y dash, which is y minus y bar. Similarly, this is x dash, which is equal to x minus x bar, and this is y dash, which is equal to y minus y. Listen carefully. If you look at the case for positive correlation, you see that after shifting origin, that means 002 x bar y bar, you see that for positive correlation cases, maximum data falls on first trio. Is it also uncorrelated when one is decreases and other is constant? Of course, trio. Yes. Actually, uncorrelated, if you look at this case, uncorrelated means either increase or decrease. If you change one variable, for changing the one variable, other variable is fixed. This means these two variables are not related. So either decreasing or increasing. If you think increasing, similarly you can decrease it. Similar thing is happening. It should be constant. Okay, Shayok, please see that diagram. Okay, Shayok, clear? Please respond quickly. Shayok. I'm waiting. Please respond quickly. You are right. Either decrease or increase of one variable, other variable is fixed or constant. This means these two variables are uncorrelated because change of one variable does not affect on other variable. So this means these two variables are uncorrelated. Okay, Pritam. Okay, thank you. So please listen carefully. I go very slowly in particular section, particular case. Okay. So if you change the origin to from 002 x bar y bar, for positive correlation case, maximum data fall on first and third coordinate. Okay. Similarly, for negative correlation, for maximum data fall on second and fourth coordinate. Okay. Similarly, if you look at zero correlation, we see that after shifting origins from 00 to x bar y bar, Shayok, I do not get your response. Please response, whether you are satisfied or not. Tell me, Shah. Okay, thank you. And one thing I request you, please respond quickly. So if you shift this origin from 0, 0 to x bar y bar, and the new axis denoted by x dash, which is x minus x bar, and new axis, this is y dash, which is y minus y bar. And we see that for zero correlation, all the points are evenly distributed. All the points are evenly distributed. Points are evenly distributed. All the four axes. Okay. So in that case, if you take the product for positive correlation case, if you take the product, then you see that x dash y dash greater than 0, because for first coordinate x dash y dash both are positive, and for third coordinate again this product is positive because x dash and y dash both in third coordinate is negative, so product should be positive. So it is obvious that the maximum number of product for positive correlation case, for maximum number of products should be greater than 0. So we can conclude that if there is a positive correlation, maximum number of x dash y dash, the product should be greater than 0. So it is obvious that the sum of this product, I denote this by I xi dash, this pair xi dash which correspond to xi and yi dash which correspond to yi. Xi dash means xi minus x bar, yi dash means yi minus y bar. X bar is the mean of x, y bar is the mean of y. So if you take the sum, then this should be greater than 0, because maximum number of x dash y dash greater than 0. This implies sum over I from 1 to n xi dash minus y dash should be greater than 0. Mind it, one point you should remember, there is no outlier, that means there is no abnormal observation present in that situation. Okay. Similarly, if you look at this graph for negative correlation situation, then you see that maximum number of the product will be less than 0, because in second coordinate y dash greater than 0. Sir, I think I have a network issue. Okay, no problem, Shayo. No problem. Yeah. If you respond quickly, then I can start new thing quickly. So that's why I'm telling you. No problem. It's okay. Okay. Thank you. So x dash y dash, this product less than 0, because in second coordinate y dash is less than greater than 0, x dash is less than 0. This means this product should be less than 0. And for fourth coordinate again, we see that x dash is greater than 0 and y dash is less than 0. This makes x dash y dash should be less than 0. So here we can conclude that maximum number of x dash y dash should be less than 0, and this implies sum over x dash y dash, this sum should be less than 0. I from 1 to n, this sum should be less than 0. And similarly, for zero correlation, since all are evenly distributed, we can expect that for zero correlation, this sum should be xi dash yi dash equal to 0. So clear? Are you agree with my arguments? First you tell me, then I go to the next. Please tell me without any hesitation, please tell me, are you agree with my argument? If yes, then please write in the comment section yes. Otherwise, tell me your doubt. Okay, thank you, Shashwato. Please response quickly. Shashwato, thank you. Nirmallo, please tell me. Okay, thank you. Thank you. Okay. So I think you are satisfied with my explanation. So therefore, we can consider this product, sum of this product, xi dash yi dash, which is nothing but xi minus x bar, yi minus y bar, I from 1 to small n, I from 1 to small n, as a measure of linear correlation or correlation, or you can say measure of linear association, because we are restrict our discussion only linear association. Okay, but there is a problem. If you increase the number of observations, then it may change the sign of this product, sum of this product. So first you need to free this measure from number of observations. So that's why I divide this measure by the number of observation n. So this makes it is free of this measure now free from observations, number of observations. So this if you this now this measure free from number of observations. But this is again there is a problem, because this is not unit free, because it has a unit and it has this is called product unit, because it involves unit of x and unit of y. So you need to free this measure from unit. So that's why we divide this measure by their SDs, that is SY, SX by SY. Why I divide SX, SY? Because SX and SY do not change the sign of this measure, that is the direction of this measure. So that's why I choose SX, which is a SD, standard deviation of variable x, which is always positive, and this is SD of variable y. So this is nothing but a root over 1 by n sum over xi minus x bar whole square, I from 1 to small. And this is equal to root over 1 by n sum over I from 1 to j from 1 to n, the dummy variable yj minus y bar whole square. So now it is not only free from number of observations, this is also unit free measure, and this is denoted by small r, which is called correlation coefficient. And we consider this as a measure of linear association. So please tell me, have you any problem? Can I rub this portion? Please tell me. So please tell me, Nimallo, Pritam, Shumon, Jeet, Shayok, Tomabu. Can I rub this portion? Please tell me. Have you any problem? Please tell me. Any doubt? Please tell me without any hesitation. So, okay, Ortho Provo. Thank you. So now we can write. Sometime this is right as not only as suffix xy. So this means correlation coefficient between the variable x and y. Okay, and this term is called covariance between x comma y. Sometimes we denote this by small xy, which is equal to 1 by n sum over I from 1 to n xi minus x bar yi minus y bar. After simplification, we can write this as you can check this. This is your homework. Similarly, we can write fx. I think it is better to write capital X. Fx. Capital X. Please write this change this notation to small x to capital X. Okay, thank you. So similarly, capital X says it is equal to 1 by n sum over I from 1 to small n xi minus x bar whole square, which is equal to 1 by small n sum over xi square minus x bar square and sy, which is equal to 1 by n sum over I from 1 to n yi minus y bar whole square, which is equal to 1 by small n yi square minus y bar whole square. Please check this. This is another homework. Okay. So after this simplification, we can write Rxy, which is equal to 1 by n sum over I from 1 to small n xi yi minus x bar y bar by root over 1 by n sum over xi square x bar square into 1 by n sum over yi square minus y bar square. For computational purpose, we use this formula. Okay. Now, this is called product movement correlation coefficient. This is called product movement correlation coefficient. Or curl Pearson, because this is due to Professor Carl Pearson. So this is called Carl Pearson correlation coefficient. Okay. So for frequency for group data, then the formula is suppose I consider L classes of X. I think I forgot. Please tell me whether I'm L or K. Please tell me. I think K classes of X, and these are the mid value. These are the mid value of corresponding classes of X. Okay, and these are the marginal frequency. And this is the mid value of corresponding classes. Mid value means upper limit plus lower limit divided by 2 corresponding classes. This is the mid value. These are the mid value of y, and these are the corresponding marginal frequency. Then product movement correlation coefficient for group data. This is equal to sum over I from 1 to k, j from 1 to L, xi star, yj star, fij. This is a joint frequency corresponding to ij plus 1 by capital N. Capital N is the total frequency minus x bar y bar, where x bar is the sum of I from 1 to k xi star fi naught divided by capital N. Y bar is equal to j from 1 to L yj star f naught j by capital divided by sx sy. This gives product movement correlation coefficient between two variable xy for group data. And one more thing I need to define, that is sx, which is nothing but similarly, this is for univariate case. And no, I think you can compute HD for group data for univariate case. So similarly, we can apply same formula here also. X bar square and sy okay. So I want to stop today. In the next class, I will discuss the property of correlation coefficient and its limitation. If time is permit, we will then discuss regression analysis. So please tell me if you have any doubt for this class. I will answer you. Please write your doubt in a comment section. Otherwise, I end the stream. So our next class on Sunday, coming Sunday, at the same time, 6 p.m. So please let me know if you have any doubt. So thank you. So we will discuss in my next class the properties of correlation coefficient. And if time is permit, then we start discussing on regression analysis for bivariate case. Thank you, Pritam. So Jeet sir will be able to watch this video later. Yes, you can go. It is here, okay. So you can check the video anytime. No problem. Thank you, Orthodeep. Thank you, Jeet. Thank you, Pritam. But one thing I am telling you, if anybody is not subscribed to this channel, they only watch this video. They cannot write any comment. So please subscribe this channel. Thank you. Till then, we will meet again on Sunday. Till then, thank you very much for watching this class.